Hello students, welcome again for Chemistry Chapter 5, Section 5.3, Lecture 2. So this is actually part 2 of that lecture. And it will begin with actually letter C, electron affinity. But again, I want to remind you that in order to help you understand, you might want to obtain this document right here of the periodic table that you've already got colored in. And also the other day I gave you the wonderful handout, this handout right here dealing with how the trends go both in a group and as well as a period. Those would actually aid you, plus your electronic textbook will actually be able to refer to some of the figures that are within that. So anyway, with that we will now begin with C, electron affinity, and it will ask you to refer to figure 5-17 and 5-18. It's actually represented in kilojoules per mole. Number 1, electron affinity is the energy change that occurs when an electron is acquired by a neutral atom. A plus the electron yields A negative plus energy. Energy released is represented by a negative number. Number 2, A plus an electron plus energy yields A minus. Energy absorbed is represented by a positive number. This ion here will be unstable and will lose the added electron spontaneously. Number 3, period trends. Under A, halogens gain electrons most readily with large negative values, which creates for high reactivities. Under B, in general, all electrons add the same p sublevel of atoms with increasing nuclear charge. The electron affinities become more negative across each period within the p block. The exception is carbon is less than nitrogen. Adding an electron to a carbon atom gives a half-filled p suborbital, making it now more stable. Nitrogen already has a half-filled p sublevel. Under number 4, group trends. Under A, the electron affinities within groups is not as regular. In general, electrons add with greater difficulty down a group due to two competing factors. Number 1, first, slight increase in effective nuclear charge down a group will increase electron affinities. Number 2, second, an increase in atomic radius down a group will decrease electron affinities. And number 3, in general, the size effect predominates, but exceptions occur among heavy transition metals, which tend to be the same size or even decrease in radius down a group. Number 5, adding electrons to negative ions. Under A, it is always more difficult to add a second electron to an already negatively charged ion, and they are all positive. Under B, add another electron to a noble gas configuration made negative ion that it never occurs. Under C, minus 2 ions do exist for the halogens, but is only achieved by adding 2 electrons to form compounds. Okay, now we're ready for D, ionic radii, figure 5-19 out of your online chemistry textbook. Number 1, an important definition is a cation, C-A-T-I-O-N, is a positive ion formed by the loss of one or more electrons and causes the atomic radius to increase. I'm sorry, it's not increase, it's decrease, to decrease due to removal of the highest energy level electrons. Also, the electrons are drawn closer to the nucleus by its unbalanced positive charge. Okay, number 2, another important definition is an anion, spelled A-N-I-O-N, is a negative ion formed by the addition of one or more electrons, causes an increase in atomic radius. The total positive charge is the same, and the electrons are not drawn to the nucleus as strongly as before the extra electron was added. The electron cloud spreads out due to greater repulsion between increased number of electrons. Number 3, the period trends are A. Metals on the left of the table tend to form cations, and non-metals at the upper right tend to form anions. Under B, cationic radii decrease across the period as the cloud shrinks due to increasing nuclear charge. Under C, group 15 and to the right gain electrons to complete noble gas configuration. Number 4, group trends. Under A, there is an increase of atomic radii down a group. We add energy levels, and there is also a gradual increase of ionic radii. And that concludes Chapter 5, Lecture 5.3, Part 2, or Lecture number 2. And anyway, I hope I didn't put you to sleep too bad today, but we will continue on with the next part. Thank you very much.